Hi, hello everybody. My name is Kate Zimmerman, and today I'll be talking about how you can use AutoML to create high-quality machine learning models. So my goal for today's session is to first go through an overview of what AutoML is and how we think about that at AWS. Then I'm going to deep dive into Amazon SageMaker Autopilot, which is an AutoML feature that's baked into the Amazon SageMaker platform. I'm going to talk a little about how customers are actually using these techniques to accelerate machine learning for their businesses, and then land with a demo to show you exactly how you can get started with a tool like Amazon SageMaker Autopilot and highlight some of the really interesting features that you might find relevant for your machine learning use case. So let's get into it. So first I want to start by defining what AutoML is, because it can be a little bit of a buzzword. People get very excited about the idea of automating machine learning. In automatic machine learning, the whole goal is to really accelerate the machine learning lifecycle. So if you think about a typical machine learning model, so first you're going to get the data that you're going to use to train your model. You then have to do feature engineering and augmentation, so you clean that data to get it ready for machine learning model training. And this can take time, and typically it's very iterative, right? So you go forth, you try one data augmentation technique, realize it didn't work, go try a new data augmentation technique and kind of repeat. But once you get to a place where your data is clean, you can then go off and train some machine learning algorithms. And here there are lots of different choices for ML algorithms out there. So you'll try different algorithms for your use case. You'll then tune the ones that work the best before actually deploying your model into production. And all of this takes time. It takes a lot of expertise in both the data science aspect, so how we can get our data to be most representative of the use case that we're trying to solve, but also a lot of machine learning knowledge and machine learning expertise that's required, and how we select the right algorithms, tune them appropriately. And all of these things create pretty high barriers to entry for machine learning. And that's exactly what AutoML is trying to help remove, is make this more frictionless, lower those barriers, be able to build machine learning models even whenever you don't have deep expertise in every single one of the areas in my little wheel here on the picture. And the whole goal is that you can spend less time on these low-level details, right? So less time getting into the nuts and bolts of how you want to do different feature engineering techniques, and more time analyzing the results coming out of your model. So you can start thinking about how machine learning can deliver mission value or business impact faster, and spend less time, again, on these more tedious and intermediary steps that it takes to actually build those models. So there are two big services that I want to talk about that are considered AutoML solutions on AWS today. The first one is AutoGluon. So AutoGluon is an open source AutoML toolkit, and it allows you to build and train very accurate machine learning models for text, image, and tabular data. We have example notebooks available, and I can show that during the demo on AutoGluon in our SageMaker example notebook repository. And those will show you how to get started with the toolkit in SageMaker to be able to use it for your use case. And the second service that we're going to spend a lot of time on today is Amazon SageMaker Autopilot. Autopilot is a little different than AutoGluon in that it is actually natively integrated into the Amazon SageMaker platform. So you'll see in the demo that we'll pull up the SageMaker Studio UI, click through a bunch of different elements. It's actually fully integrated into the service, into the SageMaker service. So where AutoGluon is an open source toolkit that you can leverage in SageMaker, Autopilot is truly a built-in feature of the SageMaker platform. And with that comes certain advantages that, again, we'll highlight later on. But kind of zooming out, so these are the two solutions I'm going to talk about the most today. But whenever we talk about AutoML, I do want to call out that it really is something that's embedded throughout the AWS stack. If we think about AutoML as being a feature that can help make that machine learning lifecycle more frictionless, help accelerate the development of machine learning models, all of our services in the platform are truthfully going to be designed to do just that, but in different ways. So if we can think about it very broadly and generically, we have kind of our lower level of the stack that's going to be focused on being able to do as much as possible. So we have raw GPUs, you could install AutoGluon, you could install more experimental AutoML solutions, you could install third-party AutoML solutions into our frameworks and infrastructure. So you can use these toolkits in whatever way you need. But again, you're going to have the lowest amount of automation being baked in by default. So the responsibility on you to be able to install those packages. But as you move up our machine learning stack and look at more of our higher order services, like our AI services, here you'll have very high levels of automation. So if you think about a service like Amazon Rekognition, which is completely pre-trained out of the box, that flywheel, basically every step has been automated for you, right? So Amazon has gone off and our data scientists have labeled the images. We've done all the feature engineering work. We've trained all the different computer vision models. We've tuned those models and deployed it for you so that you can just start making inference calls right out of the box. So here, again, this is as frictionless as it gets, definitely being the pro of using AI services. The con being that for your specific data and your specific use case, if it looks too radically different than what these top tier services have been trained on, they may not perform for your particular data type. Now we do have a couple exceptions to those. So we do have things like custom labels that are supported in Rekognition as well as Comprehend. And with custom labels, you can do some amount of customization on top of the existing models. So again, might not be automating the data acquisition piece, but we're automating the rest of our little flywheel. And then we also have services like Forecast, where it's actually using your data to train the machine learning models. So again, the data acquisition piece, you have to bring your own data, but the rest has been automated for you. So very powerful tool. And if you're looking for the most frictionless machine learning experience, I highly recommend attending some sessions on our AI services and learning more about those, because those will be kind of the lowest barrier to entry that we have on the platform today. But, you know, while these cover a very broad range of use cases, so we have AI services for vision, we have AI services for search and healthcare, the primary con here is that you don't have the deep insights into how the models were built and trained. So the pro being it's very frictionless to use, the con being that based on your use case, they may or may not be accessible to your industry or for your data type. And so when that happens, what we recommend is that customers move down into that middle of the stack, which is a little bit of the best of both worlds. So you get a lot of automation of spinning up the GPUs, you get a lot of automation and the packages preloaded, but you also get the flexibility of using your own data. And so for those, we recommend Amazon SageMaker. And Amazon SageMaker is our machine learning platform. There are a lot of features built in there. In fact, we have over 20 tools that are designed to cover the entire machine learning lifecycle. And the whole goal of SageMaker is to accelerate machine learning development and boost your data scientist productivity. So we're trying to build tools that are common. So let's say I'm trying to, detect objects in satellite imagery. My background is in space, by the way, guys. So that's kind of what my use cases are going to gravitate towards. But let's say we're trying to detect objects in satellite imagery. So things about that use case that are not unique is the fact that we need to train some kind of computer vision model because we're working with imagery. So we need to be able to spin up these GPUs. That's not very unique to the use case. Things that aren't unique is the fact that we need to use, let's say, TensorFlow or PyTorch or access these basic libraries. So what SageMaker does is it takes those things and builds tools around them so that we're not reinventing the wheel for every single project. So you can have a managed data science environment that allows us to easily spin up GPUs for training, allows us to use standard TensorFlow or PyTorch-based containers to write our code in. And it just makes the ability to build these models that much easier. And again, boost your data scientist productivity. And the goal also with all of this is reducing costs. So the efficiencies of the cloud are baked into this service. So it's meant to be scalable. You can spin up 2 GPUs and train in, a half hour. You could spin up 1 GPU and train in an hour, but all that distributed training pieces are baked in and the cost flexibilities are kind of baked into SageMaker's business model. So a very powerful platform to use in general, especially whenever you're working with your own code. And when I talk about SageMaker in context of AutoML, what I really want to hit on is, again, that Amazon SageMaker Autopilot service that I'd mentioned earlier on. Because Autopilot is a native AutoML solution built directly into Amazon SageMaker. And the way it works is you bring data. So in the case of Autopilot, this is tabular data. You select your target column of what you want to predict, and then you go run Autopilot. And under the hood, Autopilot is going to do a lot of that machine learning lifecycle for you. So it's going to go train the models and tune the models and do all kinds of cool stuff. At the end of it, you'll get a report about the model's performance. And if you choose to deploy that model, it is truly only a click. And then that model is deployed as a SageMaker endpoint so that you can go off and start making predictions. So when I talk about AutoML making things frictionless, you can really think about the fact that all we really need here is data. And once we have the data for training the models, it is only a few clicks in the console to be able to go off and start building machine learning models, which is pretty darn powerful. And really enables you to start experimenting with machine learning earlier in the business process. So you don't need to go out and hire a big team of data scientists and machine learning engineers to even start experimenting with ML. Autopilot makes it easy to start doing that now. Now, I mentioned that to use Autopilot, you have to have tabular data. So let's take a look at what that is. So tabular data is, you can think of it as like a spreadsheet, a table. It has rows, it has columns, and it can be all kinds of different values that will be inside that tabular data set. So here we have our columns as variable 0 through variable 4, and our rows are different tests, test 0 through 6. And really what's important is that we have, at least more than one column. So we need a few different variables or different features that we can use for predicting. And then you need to have that target column. So that's really key. The target column here is a 0 or 1. And the target column is basically, letting us know which elements of the rows here are what we're trying to predict. So to give you some examples of use cases, direct marketing, customer churn, I actually did a demo on this last year at reInvent. With customer churn, we had a bunch of information about the different customers in the spreadsheet. So we knew things like where they're from, how long they've been a customer, how frequently they're using the service. So we had all that data captured into a spreadsheet. And then our target column in the customer churn use case was a 0 indicating that the customer stayed with the company and a 1 indicating they churned or went to a different provider. So that's what we're trying to predict, right, is the churn. So the target column is definitely the important piece here because that's what helps us actually build models to make predictions. Definitely other use cases out there, though, customer lifetime value, credit risk prediction, again, another common, sale prediction, price predictions I've definitely seen a fair bit. We've seen a few uses in healthcare and life sciences. We're looking at different tabular data as well as risk assessment and loan risk classification. And I'm actually talking about a use case a little bit later, again, space background, about how we were able to apply this to detect illegal drug trafficking in the ocean through tabular data and Autopilot. Kind of stay tuned on that one. But once we have this data, so once we have all of our features and we have our target column, again, the previous slide, I said you click a button, you said, run Autopilot. And that's what happens. But under the hood, what Autopilot's doing on your behalf, kind of going back to the flywheel, is it's doing that feature engineering and data augmentation. So Autopilot is trying different feature combinations. It's doing some analysis to see, okay, like what values are missing? What are some ways we can augment that or work with that? And then it goes and trains multiple machine learning algorithms. And so again, with that one click, it's I know often it's going to try your data against a bunch of different algorithms and basically report back to you on which ones worked well and which ones didn't. Definitely saving you a lot of time, but also if you're relatively new to machine learning, it might not have a firm understanding of when to select which algorithm for your use case. This is a very useful tool because it's going to test all of those for you and then just give you statistics out on like how they performed. So it also can help you build that foundational kind of knowledge and intuition, a little bit of the art of machine learning about when I should use something like Random Forest or XGBoost or different algorithms for different use cases. After it trains these machine learning algorithms, go forth into the tuning phase. Model tuning is, how do I put this eloquently? A pain in the rear. It can be very iterative, time consuming. You're basically tweaking and turning knobs. This can be like a month of just trying different small ranges of feature combinations. So having it baked into the service is definitely a huge help. So not only is it telling you which algorithm you should use, but then it tunes it, which is wonderful, and a huge time saver. And then it also provides you a report on how it all performed. Once all these steps are completed under Autopilot, under the hood, which by the way, this is like hundreds of short little training jobs. I'll show you guys in the demo just how much work this is. It goes forth and deploys the model. Now this part, there's a check, right? It doesn't automatically deploy it. You'll review statistics, and if you like it, you can just click a button to deploy it. But once it deploys it actually takes the top performing algorithm that's been tuned, packages that into a container, and then deploys it so you can then integrate that into your business applications through the SageMaker API. So you can start putting this into production and using it very quickly. Autopilot is bringing a lot of automation to the machine learning process. Really, the only thing you need to worry about is your data. Making sure that you have the right data for your use case, and making sure that you have a target column that shows the predictions of what you're trying to achieve. What I have found with most customers that I've worked with on Autopilot is that the data piece is where they end up spending the most time. So they'll bring in a data set, run Autopilot, the model won't perform as they expected. They'll go through and evaluate the output of Autopilot, realize that perhaps some of their features were redundant, some of their features had too many missing values that were impacting model performance, and then they'll go forth and iterate on their data acquisition and then go around the flywheel again. But what's really nice here is that we're focused on the thing that I would argue is easiest to understand, which is the data, because that's what we know, right? Data is very specific to our business, our use case. And so we're focused on just getting the data right and not worrying as much about how we want to tune the different hyperparameters and spending months iterating on those little guys. So again, a huge accelerator to being able to build machine learning models. I'm going to get a lot deeper into how this data acquisition piece, what we give you to help, right? So Autopilot's going to give you tips and tricks to help you figure out how to automate on that data acquisition part a little bit faster. But just kind of before I get into that, I want to reiterate these core features. So this is very easy to work with, this tool, quick to start. We have the options to work within the UI built into Amazon SageMaker Studio, or you can work within a notebook. We provide example notebooks for you to get started from. You'll see my demo later today that will also have some code that you can use as a starting point. But again, very simple to write. You'll find that these Python scripts are not particularly complicated, with the goal being of making Autopilot as accessible to the broadest audience as possible. We have automatic model creation that happens. So again, click a button, that flywheel spins, and at the end of it, you get a machine learning model so you can go forth and evaluate. And all that's just baked in. So again, you really do just click run and all that happens under the hood. You get visibility and control, and I'm going to show you some examples of this. Autopilot is not a black box, and this is definitely a big differentiator from some of our other AutoML-esque features or services in the AI services part of the stack. You're actually going to get notebooks with source code as an output that you can then go forth and execute. And so that's a big differentiator that Autopilot has from other AutoML solutions in general. It's a very cool feature and something that's unique to this particular service. And then you also get lots of recommendations and optimization. So I mentioned that the data acquisition piece is where people iterate most. So Autopilot isn't going to kind of leave you hanging there. They're going to tell you, hey, these features had a lot of missing values. We think it impacted performance. We think that there are things you can do here. So they're going to make recommendations to you on how to perform, how to improve the data acquisition piece, be able to improve the performance of the model. So I'm going to show you these kind of in person during the demo, but just kind of get you excited for what's coming up next. This is an example of the dataset exploration notebook. So whenever Autopilot does the feature engineering step in our little circle, our little ML lifecycle, it's going to try a bunch of different feature engineering data augmentation techniques. It's going to try to handle missing values. It's going to bin things and for categorical variables, translate those into different numbers. And it's going to tell you what it did, and it's going to show you. So you're going to be able to see the notebook coming out of all the different things that have happened. And it's also going to include suggested action items. So if there are things that it found in your data set that indicate that it might not might be impacting model performance, definitely not ideal for training models. It's going to flag that and kind of explain it to you so you can then go forth, look at the data, and then see if there's something you can do to iterate on that. And it is executable code, so you can rerun these same techniques. You can change the code a little bit, see maybe, well, if I changed it to this or that, let's understand how it impacts my data. But again, all that's available for you as an output from the training job. Similarly, for the algorithm training piece, where it tries a bunch of different machine learning algorithms, that also is going to be outputted as an executable code in a notebook. And so you can actually see, which algorithm did it try. Did it try random forest, try linear learner? Did it try XGBoost? You can see not only which ones it tried, but also the hyperparameters that it used and different tuning jobs and such. So again, far from a black box, you actually get the code that it used to execute and actually train those different models, which is pretty cool. And lastly, I want to highlight a newer feature of Autopilot that was also available as an output, which is an explainability report. And this gives you the feature importance, which this is, I think, pretty cool. So it's actually using Amazon SageMaker Clarify. And what it'll tell you is how each attribute contributes to the predicted result as a percentage. So we can say that for the customer churn example, if their plan type is the biggest contributor, so it's not as important how long they've been with our particular company. It's not important how many minutes, let's say, they're using our service per month. What's most important is the plan type. And that's overwhelmingly biasing our predictions. That will be given to you in this report. And sometimes that indicates to you that perhaps your data, your features probably aren't what you want. Maybe they're not as representative as what you're looking for. And other times it's just insightful. I mean, it might make sense that customer plan type would be the biggest indicator. Perhaps you have 1 to 2 year plans, but then you also have a monthly option and you see the most churn in the monthly option. You're like, yes, that makes sense. No surprise. But this is just gives you that little sanity check, right? To understand that like the features that you have in your tabular data set are predicting as you expect. And also that you don't have any one feature that's overly dominating so that all the decisions are just off of one. I know it sounds silly, but I have definitely seen it, where you might have a target column that has something like customer churn, but then you also have somewhere in your variable, so maybe a feature somewhere that says, has the customer left, yes or no? So you already basically have your target or your ground truth in your training feature set. And what you'll see coming out of something like Clarify, if that was the case, is that would be by far the dominating feature, right? So only almost, the model's prediction would be like 100% based on the fact that you had, did the customer leave, yes or no, as a feature, right? Because that's all you need to know. It's basically the same thing as the target column. So it also helps you find those kinds of whoopsies and red flags and big mistakes very quickly, very easily, so that you don't find out later on that you had bad training data. So again, a very useful tool, and I'll show you guys this in the demo. But before we get to the demo, I wanted to take a quick moment here to talk about a couple of customer use cases and stories of how I've seen Autopilot be used by AWS customers. So the first one I want to talk about, I'll admit I'm a little biased towards because I work in the Amazon Machine Learning Solutions Lab, and this is a project that we actually did. And there are blog posts on this that I recommend you check out. We have 2 blogs, one on the Autopilot solution and one on another technique that we used that relied on Deep Graph Library. But to give you an idea about this particular use case, so Hawkeye 360 had a bunch of information about different shipping vessels. So these are boats or ships in the ocean that might have goods on them that are moving between different countries. And each of these ships has to transmit its location. So it says, hello, I am, the Amazon shipping vessel transporting a bunch of ballpoint pens across the Pacific Ocean. And so that information gets transmitted. So what they were looking at was that information and the geolocation of where that boat was located when it transmitted that information. With the idea being that there's certain vessels in the ocean that we know are known to be up to nefarious things, right? That we know these different vessels are pirates. We know that this is a stolen boat, or that this one potentially has drugs, or the country that it's originating from is known to be a source of drugs in the ocean. So we're able to flag those as being kind of high risk ships in the ocean. And then we looked at the geolocations of other ships and said, okay, well, if you were in proximity of a high risk ship, then we're going to flag you as well. So that countries that are monitoring shipping vessels coming in and out can know automatically whether or not they should, inspect a ship a little more thoroughly because it has a higher risk of transporting illegal goods. So basically all this came into a giant spreadsheet. So the spreadsheet had information about all the different vessels. It had location points of what proximity they've been in. And then we had our target column of whether or not this was considered a high risk vessel. So 0 being non-high risk and 1 being high risk. And we started by trying to build this model manually. So a data scientist on my team, he, was very experienced actually. He's very smart. And he spent probably 3 weeks trying to build a model that would be able to predict the high risk, whether or not this is high risk based on the information that we had. And the results were not so great. So I think we were getting about 64% recall. So slightly better than guessing, which is 50%. So, he's kind of thinking that maybe this data is not good. Maybe our features don't have enough information in them to really be able to predict whether or not this is a high risk ship. So we're thinking about maybe having to go back to kind of square one, back to that data acquisition piece and see what we can do to improve our data. But before we did that, we thought, hey, let's just try autopilot and see how it performs. And so that's what we did. We put the spreadsheet, the data, into autopilot, clicked run, let it run, came back a couple hours later, and we had a recall score of 76%. And once data scientists looked into the results of that, he was like, okay, I can see here we're looking at things like Clarifai, being able to look at our model candidate notebooks, our data acquisition notebooks, that if I change these couple of columns, I can improve it further. And that's exactly what he did. So because autopilot can search so many models and so many features, that even if you have an experienced data scientist, it's just the scale that it brings to the problem that really differentiates it. And I would say, with AutoML, I know it's about kind of removing friction, but it also can really bring scale to the problems that you're trying to solve. It allows you, when you bring a data set, to explore lots of different algorithms, lots of different features, lots of different hyperparameters with a click of a button. And so what we quickly found was that, the algorithm we were thinking about would work was actually not the one that worked the best. So we were off trying to use the wrong algorithm. It was not what our intuition told us, but the results didn't lie, right? So once we made that pivot, we were able to show some real success, and we're able to demonstrate alongside Hawkeye that we can predict whether or not there's a risky vessel, and this can be a very useful tool for countries to be able to detect illegal shipping traffic faster and more accurately. So very cool results, and I'll give Hawkeye a little pitch here. So it is available in their mission space tool. So if you're interested in using this technology, you can leverage that in their mission space product. Another example that I want to give was actually with Western Union. And here they were trying to use SageMaker to Autopilot to really personalize experiences across digital channels, which is critical to Western Union's digital banking strategy. And to power these experiences, they needed to develop machine learning models. And, building models, again, it requires the right machine learning expertise. It takes a long time to prepare, test, and optimize all of your parameters in order to find the best fit for your data. So what they found was that this was just taking too long. It was delaying the time to market for certain data products. And what they did was, okay, well, how do we make this faster? AutoML, right? Let's try to use SageMaker Autopilot as our solution instead of having to do all this manually every single time. And so what they found was that Autopilot really did help them automate the build, training, and tuning of the best machine learning models on their use case, and it also lowered their operating cost because they were able to get to the model they need faster. So these are, again, just two examples that I wanted to give you of customer stories. There are many more out there, But before I belabor the point, I want to talk about, switch to the demo here and actually show you a lot of what I've been talking about this whole time, and really hit home just how easy this is to use, and how kind of robust the training process is. We're going to train hundreds of models here with just a click of a button. So with that, I'm going to pivot to the demo.
So here we are in the AWS Management Console. Now, I kind of want to rewind quickly here. If you recall a few slides back, I had the 3 layers and talked about the lowest and highest levels of automation within the Amazon machine learning stack. And I mentioned these AI services that are available. And I will say that if you have a use case that you think might be a good fit for an AI service, I just want to point out that they're very easy to test out. So when I say, fully automated, that's exactly what the AI services are. So if we go into something like Amazon recognition, in the console here, we can try a demo. So we could say, all right, like, here are some pictures of, stock photos that we could use. But you can also upload your own images. So if you wanted to see if perhaps your brand logo gets detected, or it's detecting people wearing, a certain shirt or something to that effect, you can go ahead and check that out really quickly within the console. So it's very easy to experiment with these and see if they'll work. And if they do work, it's a huge, time savings to be able to use one of these right out of the box. Additionally, you have support for some customization in these top layer services. So for example, recognition, you can use custom labels. So you can actually upload some examples of the specific thing that you're looking for. For example, if your logo was not automatically detected, it's something for a smaller business, you can actually create a data set of that logo and upload it. And then it'll fine tune it to your exact object that you're looking for. So again, these are very, very easy to use and very easy to check out and experiment with. So I recommend, if you have a use case that might be a fit for the top layer, check it out, give it a try. It could be a huge time savings if it works. Now, if you find that your use case is not a good fit for this top layer for AI services, that's when I would recommend exploring more of these SageMaker-based AutoML solutions. And I'd mentioned 2 AutoML solutions, the first one being AutoGluon. And if you're interested in using AutoGluon or learning more about AutoGluon, I have 2 resources I want to recommend for you. The first one is within the Amazon SageMaker examples repository. This is in GitHub, AWS, Amazon SageMaker examples. If you actually come down to advanced functionality, you'll be able to find an example notebook. So here we have AutoGluon Tabular. So these example notebooks are for getting started with AutoGluon. They'll teach you how to use the SageMaker containers with AutoGluon running inside. So that's one resource. The other resource is, of course, the AutoGluon documentation webpage. This is auto.gluon.ai. If you just do a quick search on the internet for AutoGluon, this should come up. And you can actually see example notebooks for not only tabular, but also image prediction, object detection, and text prediction. So again, Autopilot, which is what we're going to focus on for the remainder of this demo, is designed for tabular data. So if you have a use case where you want to apply AutoML to imagery or text, AutoGluon is a great resource for that. So you can actually find these different examples here that you can leverage off of the AutoGluon documentation webpage. So those are 2 resources for AutoGluon. This is a good resource in general, though, for SageMaker example notebooks. So I'm actually going to be running some notebooks out of the Autopilot folder here in a second. So there's a few examples that you could leverage if you want to try some other example notebooks with Autopilot later on your own, or if you wanted to recreate the demo that I'm about to show you, that code is available here under SageMaker Autopilot Direct Marketing. So all this is kind of baked into Autopilot. So, baked in the example notebook repository, and you have lots of good code here for Autopilot. All right, so going back to the console, I'm now going to go to Amazon SageMaker. And you can get here by just typing SageMaker into the search bar. And we're actually working in SageMaker Studio. If you're not familiar with SageMaker Studio, there's a Get Started over here, or you can go to SageMaker Domain and then click Studio. So I have one pre-built, but if you have never used Studio before, you'll go to Add User. You'll create your profile name, autopilot demo. You can create execution roles, so create a new one if you don't have existing roles, or if you do, you can use an existing one. And then you'll click next, and that will create your SageMaker Studio domain. I already have one created, and I also already have it open, so I'm going to jump over here into Studio. And the first time you open it, it's going to look something similar to this. So you'll have this launcher page with some landing apps to look at. Your folder will be empty, but for Autopilot, right now there's a nice little call it up here, so you can create new Autopilot experiment by clicking up here. Alternatively, if you come down to ML tasks and components, you can find new Autopilot experiment. And if we give that a click, it's going to open up a little screen for us. So let's do Autopilot demo. So we'll give our experiment a name. We need to give it the location for our training data. Now I am going to pull this location from a different notebook. So avert your eyes. Don't look at all the scrolling. I know it hurts. I just need to get these two fields out of this notebook. So this first is the location of my training data, which is just a CSV file. And then I need to select my target columns. This is what we're trying to predict. You recall it's that last column. Now, in this spreadsheet, in our training data CSV, that last column, we need to know what the name of it is. So here is our CSV data. We have the age, what type of job, when I've been married, and we're trying to basically target advertisements towards these different customers and figure out whether they buy our product. So yes or no, yes, they bought the product, no, they did not. And this column is named lowercase y. So if I go back to create experiments, target column would be a lowercase y. So you need to make sure that you have this called out. So if you had your own data set, you'd want to make sure that you have, some kind of, and this is actually reading from, you'll see this is actually reading from our CSV file. So whatever your data set looks like, whatever your columns are, this would match those, but just make sure that you call out the correct target column. All right, and then we need to select our output location. So let's do the same, but we're going to call it output. All right, select machine learning problem type. We're going to use auto because this is AutoML, of course. If you did know exactly what you wanted to, you have the option to narrow it down. Do you want to run a complete experiment? Yes, we do. However, if you wanted to just create those notebooks I was showing you screenshots of, you could do that too. All right, and we have the option of auto deploying an endpoint. I'm going to turn that off for now just to save some time and hit create experiment. All right, and now it is off, building us a model. So like I said, you just click run autopilot and the magic happens. Now, this is, of course, using the UI. You're not required to use the UI. So this notebook that I was pulling data from is actually the same thing. It's creating the exact same autopilot configuration using the same data set. The difference being, of course, that here we are using Python code. And again, because this example notebook is in that GitHub repository I just showed you, I'm not going to spend a ton of time going line by line into the code. Also, that might be a little boring. So let's skip that and get to the interesting parts. So here we can see we actually started our training job using the Python API, and it's doing the exact same things that are going to happen in here. So we can see there's feature engineering, model tuning, explainability report generated, and those match the steps that we see happening in here as well. So it's the same thing, just a different way to start the autopilot job. Now I want to skip to the results because this one's going to take a little bit to run. This takes about 30 minutes to run for the example notebook. And once we have the sum, we actually can deploy this and we can do things like batch inference. So here I'm able to kind of test the performance using batch inference. But I think what's more interesting that I want to spend some time on is these notebooks that come out. Because, one of the things that's really cool about Autopilot is that it's not a black box, right? It's a white box, and that we can access all of the information that we need. So we have these candidate notebooks that actually get outputted. We can see exactly how our top performing candidates were generated. These are of all the models that trained, here are the 5 that were the best ones. We can also see our data exploration notebook, so how it did the feature engineering work up front, and then we can also see our explainability notebook. So the first one I want to show is this data exploration notebook. So it kind of gives you a quick rundown. So there were about 33,000 rows in our training data set. There were 21 columns. The target column was named Y. So identify this to be a binary classification because there were only yes and no in that Y column. So you can't have multi-class, but this, because it's just yes and no, it was a binary classification problem. And it gives you nice little kind of reminders and tips to look for, so make sure that your input headers are correctly aligned, so nothing went awry whenever we were uploading this into S3 when we were doing our pre-processing. It gives you some tips on some common errors. So here we don't have any missing values, so that's good. It would have flagged those for us. It also helps with these types of little things. So for example, US and US with periods in there will count as 2 different words. So it warns you of these different things and then gives you samples so you can take a look and correct your data or edit your data if it's something in here that gets flagged. This just helps kind of give you a quick sanity check on your data, make sure that what the model trained on is what you were trying to train it on, and then of course flag any potential errors that could be impacting your model's performance. So you could get higher, accuracy or performance if you correct these different things. This is that first notebook, the data exploration notebook. The second notebook that comes out is this candidate definition notebook. And this is actually getting into the training piece. So we can see how it got set up. We can see the candidate pipelines. We can actually, it has executable code in here, so we can actually see, this is code that we could run. It also has, like, for example, the hyperparameter tuning job configurations and all that great stuff. So it's all baked in and available to you, so you can see exactly how it trains the different models and down selected to the best performers, and then tunes those. Now, alternatively, because Autopilot is with this native integration into SageMaker, it also works with SageMaker experiments. So if you click on the bottom guy here, this little triangle within Studio, this can be your SageMaker resources. You can go to experiments and trials. And you can see over here, I have all of my experiments here for this particular Autopilot job. So if I open up one of those, I'll get a nice little view like this. I can select these different, the training job, transformation job, processing. So we'll do training job. And we can see the different metrics coming out. So we can see validation accuracy, the F1 binary. We can see the parameters that were used. So we can see that you used a k-fold of 5. Its tuning objective metric was optimizing for F1 binary. So all of this is captured within experiments. So it's very easy to do an analysis and understand, here we have the code of how to do it, but here we have, I prefer this view instead of looking at that, of actually looking at the different configurations of the training job. So again, all baked in, and that's what I'm talking about, like the native integration to SageMaker is such an advantage with Autopilot because it's just very easy to use all these different features that are already built in to the SageMaker platform. And so the final notebook I want to call out here is our explainability report that is generated from our Autopilot job. So here, this is actually one of the other outputs that come out. We can see, there were 20 input features that were trained on. Here are those features kind of stacked out. Here are top 10 with the greatest feature importance. So, and our employed had the greatest impact on our model's ability to make predictions. Age had the least when looking at the top 10. Now there's 10 beneath here that have even lower scores, but this just gives you an idea of how your model is making its predictions. So NR employed, duration, These are the features that are having the biggest impact on what the prediction is. So if you saw, one feature up here that was really skewing things, like you would understand there's kind of some bias towards that particular feature, and you can kind of flag those, and it just gives you a good understanding. Now, if you're not familiar with the techniques that are used to build these reports, this is built off of SageMaker Clarify. And another great resource, in addition to those example notebooks, is definitely going to be our SageMaker documentation. This is our developer guide. So if you just search SageMaker developer guide on the web, this should come up, and we can actually see all these different features spelled out. So here we have a section for autopilot. And then if we are in here, we can go down to explainability. And it says, okay, autopilot uses tools provided by Clarify. And it's using this concept of a Shapley value to be able to create that nice little graph that we saw. So we can actually learn about the math and all the good stuff that goes behind creating those charts. We can also see how this is used for explainability. So we have all the documentation here to help you interpret what this means. We also have documentation to help you understand the models themselves. So if you were using, let's say, you found XGBoost as the top performing, so that was what Autopilot told you is, hey, this XGBoost model was your best candidate. And you're like, okay, well, how does XGBoost work? Let me understand what this actual algorithm does. Again, that's all in the documentation. So you can take a look at that. You can dig into the hyperparameters and understand what it tuned and what those different knobs did. So all of that's in this documentation. So again, a really great resource in addition to our GitHub example notebooks. So if you're getting started, those are the two places I would look to understand, to get some code to start working with, but also to understand what all these different outputs mean. All right, so let's take a look. Let's see where we're at. So our model is still in the pre-processing phase. But once this starts, moving along, we'll see these different things turn green. I don't think we'll have time in today's demo to go, through all of these. But again, the outputs will be these different notebooks. You can deploy your model directly as an endpoint and get using it right away. So a very streamlined machine learning experience, truly only a few clicks, and behind the scenes, a lot of, complex machine learning algorithm training and model selection is happening, on your behalf. So if you want to be able to train a lot of models really fast and be able to explore the decision space surrounding your data very quickly, Autopilot is phenomenal for that. It helps you achieve a scale that if you were to, do this all by hand individually, it's not feasible. And so this is a very, very powerful tool for being able to explore new data sets, being able to get using with machine learning, even if you aren't, a deep machine learning expert, and also helping kind of scale your data scientist workforce in general, right? So even if you have a data science team, you could use a tool like Autopilot to be able to train lots of models very quickly and understand your data faster. All right. So let's go back to the presentation.
All right, well, thank you. I hope you learned something new today. I hope you see how AutoML can really bring value to your business or use case. And I thank you for your time today.